Okay, this ladder AB, 6 meters long, got a mass of 30 kilograms, so that's 30 G at the center, downwards, because it's uniform. It says somewhere it's uniform, 60 degrees with the horizontal. A man of 70 kilograms stands on the ladder 2 meters from the base, and it's in equilibrium. And we want the magnitude of the force exerted on the ladder by the ground, okay, for 6 marks. So I started off drawing a diagram, and then I resolved vertically. Now vertically, you got RA going upwards, and you got the 100G going downwards, so RA equals 100G. Horizontally, F equals RB, and you also got the friction. And then I took moments about A, so 2 times the weight of the man, and you want the perpendicular component of the weight of the man, plus, so that's clockwise, and the 30G is clockwise, and that's 3 meters, that's at the center, times by the cos of 60, which makes it the perpendicular component, is equal to 6 times by RB sine 60. So I simplified that. Cos 60, remember, is a half. That cancels the 2 at the start. And I just worked that out. My sine 60 is root 3 over 2. I rearranged that, and I got RB is equal to 216.89. Now I should have wrote, well, it says on the left, RB is equal to F. So that's really important, that is. So even though I worked out RB, I've really worked out F as well. And then all I did was, to find the magnitude, I did a Pythagoras calculation with RB, which was really F, and RA, which is 100G, and it came to that. They could ask you the angle, in which case you do tan to the -1 of the vertical divided by the horizontal, RA over F, tan to the -1. That's if they want it to on the horizontal and they don't want it to the vertical, in which case you would have reversed it. Okay, let's do part B. Right, this time he climbs further up the ladder, right? So you know it's going to be bigger than 2. And they're giving us mu as 0.4. So I'm just going to put that on there. Now, normally I would draw a fresh diagram if anything changes, but all that's happened is he's moved up. So if you imagine the distance from A to the 70G, I'm going to call that X. So again, I took moments about A. So X times 70G cos 60 plus 3 times 30G cos 60 is equal to RB sine 60 times 6. So basically it's the same as when I took it last time, but then I knew what that distance was. Now I don't, I'm just calling it X. I just simplified that. And I've said, well, RB, which is equal to F, from the resolving horizontally, and F is equal to mu RA. Mu is equal to 0.4, and RA hasn't changed. Okay, RA is still, when we resolve vertically, RA is still going to be equal to 100G, and that works out to be 392. And I multiply that by 3 root 3, change everything into whole numbers and just solve that simple equation. And I got x is equal to 4.65 meters. When you work that out, always make sure, is your answer sensible? Yeah, well, they've already said it's going to be more than 2 meters, and it is less than 6 meters, which is the length of the ladder. And part C, state how you have used a modeling assumption that the ladder is a rod. Well, it's a rod, so in modeling terms, it's got no thickness and it's also rigid, right? So it doesn't bend, with the weight of itself and the weight of the man. Okay, hope that was useful. Cheers.